thank you very much for this invitation. I'm glad to be here with you, and I hope I can be sufficiently brief to tell everything I would like to say. Yeah. Well, this is the line of my presentation. I will tell you something about some data, some details about my university, the Universidad del Valle, and also about my faculty. I will then talk about our master program in aerospace engineering, and I will show some numbers and projects we have done. And finally, I hope I will have time to talk about acoustic technologies for aerospace application, which is one of our research lines we are working hard today. In particular, I would like to talk a little bit about high power vortex beams for angular momentum transfer. Right. I have a video from my university, but I will prefer, if I have time, I will show you later the video, right? But I just wanted to say that my university is located in Cauca Valley. This is the southwest of the country. Cauca is one of the main rivers of the country, and we have different campuses in the department, right? We have more than 30,000 students, and these students are, in undergraduate programs and graduate programs. More than 500 doctoral students, and almost 2,000 master students, right? We have 348 academic programs, and we are around 1,000 professors, tenured professors. Sorry. Okay. My faculty is the Faculty of Engineering. We have 45 academic programs. 20 of them are undergrad programs, and we also have 25 graduate programs. I will focus on these graduate programs. We have 11 master programs. One of them is the engineering master programs, in which the emphasis in aerospace engineering is the one I'm going to talk right now. I would like to say that this faculty it has nearly 10,000 students, and I'm proud to say that 93% of these students are from low-income families, right? Our university is quite important for social promotion in our region. We have 10 engineering schools, right? One research institute, and 48 research groups, and 195 professors. 70% of them are PhD, or they have a PhD degree in our faculty, right? We also have 73 laboratories for teaching and research. Well, if I talk about the master program in aerospace engineering, it was created in 2009. I have to say that the Colombian Air Force has been quite relevant for the creation of the program. On all the initiatives we have had in our university. It has a duration of 4 semesters. In this program participate 14 professors. 11 of them are PhD and 3 are MSc professors. And there are 4 engineering schools involved. And the program is aimed mainly for aerospace, aeronautical, mechanical, and electronic engineers mainly. But also similar backgrounds are also welcome. The three research lines of our programs are aerodynamics and propulsion, aerospace materials and structures, navigation and automatic control. These are our three research lines. And there are 6 research groups that are involved or that have been involved in the works that the students have been doing in the program. You can see here the list of research groups, right? Okay. Right. The main achievement of this program and the main satisfaction of this program is in fact to contribute to the space culture in our country. That's when we started, we were, well, actually we are pioneers in graduate programs in this subject in the country. And at the moment we have 16 graduates and 5 current students. And we are proud to say that most of these alumni are working today in research and development. And 3 of them are PhD. They have a PhD today. 2 of them are current PhD students. 4 of them are part of the Colombian Air Force. And even one of them is working for a Brazilian company, which is called Avibras. And he is a senior researcher in antennas. So we are happy to say that in spite of the complicated or difficult that has been to improve or talk about the space as a subject that is worth to pursue, you know, to study deeply, right? In a country like ours, we have found quite a very, very, very interested students and very good students that allowed us to do research in this subject in different topics, right? Not only in the topic I'm going to talk a little bit, which is acoustic technologies, right? So we are happy for that. We know that this is a low number, but comparing the options or the dynamics that our government and our country has had in this subject, I think is a good number, right? And the quality of the works is also something we are proud of. Right, here we have a list of collaborators and partners, and I would like to just for information, some of the topics I would like to say that the topics are quite diverse, right? And they are somehow focused on technologies. And one of them is angular momentum estimation transferred by acoustic vortex beams, defect detection in composite materials using land waves, geostationary orbit for the satellite FAXAT-1, and determination of operational commercial orbit for the satellite mission FAXAT-2. We are happy to say that somehow we have contributed to the FAXAT program that Colonel Garzon have talked about just before. Another project is numerical modeling of combustion process for hybrid rocket engines, design of high power vortex beam using ultrasonic vibrations, the ultrasonic radiation force and its potential for modal analysis, implementation of the random vibration standard test for environmental verification of macro satellites, design and evaluation of nonlinear control strategies for attitude control of a CubeSat in orbit, and design and implementation of omnidirective microstrip antenna for circular polarization for rocketry applications. These are 10 of our master thesis titles, right? I included some of them, right? Actually, we only have, as I previously said, 16 master thesis for 16 graduates. Right, if I have time, I would like to mention or to talk a little bit about one of the main subjects me in particular and my team, we are working on, and it is acoustic technologies for aerospace applications. The first thought might be that acoustic is not useful in space because there is nothing in space, and you need an elastic medium in order to propagate a wave, a mechanical wave. But what we have found out is that there is plenty of room for acoustic applications in aerospace. And I would like to talk about a subject which is quite singular, and it is the vortex beam, or the possibility of transferring momentum to matter without contact or without touching the matter by means of a vortex made out of sound, of ultrasound, right? A vortex beam is a beam whose wavefront is a helicoid, actually. And if you have the opportunity to take a picture of a vortex beam and take a transverse section of the beam, it looks like the video you have in front of you now, right? You see the blue area is the low pressure zone, and the red one is the high pressure zone, and the wave propagates like that, right? In air or in fluids, right? In liquids, right? The most interesting characteristic is that it has a singularity, a phase singularity right at the center. That means the phase is not defined. And because of this, the pressure is null, is virtually zero at the core of the beam, right? So they can be used for particle and object manipulation, for alignment, for ultrasound communication, among others, right? They also exhibit self-reconstruction capability, which means that if you occlude the vortex,
en este proyecto de conocimiento de
you will have they will reconstruct later in space, right? So this is a slide to show you that this is the wavefront. The wavefront is a helicoid, right?
Professor Joao, we have just 1 minute.
Right. Okay. Good. So we have developed different technologies. I just want to show you some videos, right? So we create vortex beams. You're able to transfer matter like you can see in the video, right? You're able to levitate and move, right? I'm gonna continue, right? This is a vortex beam. This is a vortex beam propagating. This is measured. All these videos are experimental results in our lab, right? This is a vortex beam measured in air. These are different technologies we have developed. This is also a vortex measure. That's the way it propagates, right? It was measured at different transverse planes, right? Using calibrated microphones. These are different technologies we have developed, right? We are also able to control the beam so that by moving, by change the frequency, you are able to manipulate the structure of the beam as it propagates. And we have also developed high power vortex beam. I will finish with this video, right? And here you can see the beam generator is the silver plate you can see at the bottom right of the video, and on top of this, without contact, there is a cork disc which is separated by almost 4 centimeters from the plate. And we were able to accelerate this cork disc up to 7 revolutions per second, right? This is the highest vortex beam, higher torque we have achieved, and we were able to transfer. We applied the estimated torque is about 17 dynas per centimeter, and the momentum transfer was 173 grams per centimeter squares per second. Right. There are several alternatives for vortex beam generation, and we are working hard on this. There are some potential applications in ultrasonic propulsion, in satellite attitude control, in non-contact modal analysis, in mechanical sample characterization, among others, right? Also, acoustic levitations can also be used for microgravity simulation. Thank you very much, and sorry if it took me more than